Hello everybody. In the last two videos we talked about buck converters and we now know how a buck converter works. We manually switched a buck converter in the first video, and in the second video we used a pulse width modulated signal to switch the circuit and see how it behaves. In this video we will talk about switching a buck converter using an Arduino. You can use any other microcontroller to do this. You can also use a 555 timer to do the same, but we are using Arduino just to see the principle of work and to also give you an idea how Arduino works. So our circuit is the same circuit as the last time. It consists of the buck converter, which is essentially an inductor and a capacitor with a diode, and a switching element, a P MOSFET in our case. Now there is also the load. We used a load of 1 kilo ohm and a load of a LED with a limiting resistor and also a 100 ohm resistor, just to demonstrate how load will affect our output voltage. I used a switch here because when I run this simulation I will show you how loading and unloading the circuit will affect the output voltage, and the Arduino will respond to with adjustments to the pulse width modulated signal and will adjust the output voltage to the desired voltage. So the circuit is the same, but we added a few things here. The first thing is the Arduino. I used Arduino Mega, but you can use Arduino Uno or any other Arduino board you want. You can also use any other microcontroller as a big microcontroller to control this circuit. Now the Arduino, it has we will use only 3 pins in this video. The first pin is after connecting the Arduino to a power source, 12 volt source and the ground. We will use the first analog pin in Arduino A0 to set the desired value for the output. So this pin is the set value. Now the set value, we will take it from a voltage divider. If you see here, this is the set value. I used labels here just to reduce the amount of wiring. In Bluetooth or any other CAD software, you can actually manually connect wires between nodes, but this will make your layout messy. So you can use labels to connect them by names. So this node is the set value and this node is the same node, so they are internally connected. So the set value will be put using a voltage divider. We will use a 20 kilo ohm resistor connected to the 12 volt power, and this resistor will be connected also in series with a potentiometer. This potentiometer is 10 kilo ohm potentiometer. This means that the point between the two resistors will take, at its maximum, will take third of the 12 volt, because a voltage divider always divides the voltage on the resistors based on their value. So the 20 kilo ohm will take the bigger value and the 10 kilo ohm potentiometer will take less of the 12 volt. Now if you make this potentiometer 10 kilo ohm at its maximum setting, it will take third of the 12 volt. So this will be 4 volts. And if you make it at its minimum, it will take 0 volts. So we actually feeding the Arduino with a 0 to 4 volts value, and we feed it through the A0 analog pin. Now the Arduino will read this analog voltage and will use it to generate the pulse width modulated signal. The other pin we are using is the A1 analog pin in Arduino, and we will connect it to the output feedback. We can use this system without feedback. We can make it open circuit system, But in this case, we will not have any control over the output if there was some loads or loading or unloading. So the voltage at the output will drop or maybe change without the Arduino sensing the difference. So we need this closed loop, the feedback, we need it so we can adjust the output based on loading or unloading conditions. So the feedback is actually also a voltage divider. We will take the output voltage and we will divide it on 20 kilo ohm and 10 kilo ohm divider. This will ensure that the feedback signal taken between those two resistors will always be less than 5 volts. We need to ensure that the signal will never go above 5 volts because Arduino cannot accept voltages more than 5 volts. You will destroy the chip, and for protection you need to make sure that any voltage read by Arduino will be less than 5 volt. So since our biggest voltage in the circuit is 12 volt, even if we set the value we need on the output for as 10 volts, for example, and the output was 10 volts, the 10 volts will be divided on 20 kilo ohm and 10 kilo ohm. So the feedback voltage will be always a third of the output voltage, and it will never exceed 4 volts, since the output voltage can never exceed 12 volts. So this voltage will be fed back to the Arduino analog pin, and the Arduino will read it, and it will decide if it is actually the value set by us or not. If it is more than the set value, Arduino will decrease the pulse width modulation and will try to decrease the output voltage. And if the output voltage was less than the set value we determined before, the Arduino will increase the pulse width modulated signal to increase the output voltage and to set it at the level we want it to. So this is the 2 pins in Arduino. The third pin is the digital pin number 4, and this pin is responsible to send the pulse width modulated signal to the circuit. So we will generate the signal inside Arduino, and we will send it from this pin number 4, to pulse width modulation node. Here is the same node as here. It is connected to the base of the NPN transistor. This NPN transistor is responsible for switching the P MOSFET on and off. So we actually switching the P MOSFET based on our pulse width modulated signal generated from Arduino. So now our circuit is complete. We can use it and simulate it. For the code of Arduino, I will show it after at the end of the video. I will show you how we programmed the code, but I already uploaded the code here and it is working now. If you see now, I will start simulating the circuit, and you will see that our voltage here now it is 0.38 because our settings is 0. You see the setting here is not set properly, so we will just adjust the potentiometer to get, it's 6 volts now. I will adjust it to 5 volts. So our set value now is 5 volts. Okay, and Arduino is doing the job and generating pulse width modulated signal to keep the voltage at the red here. You will see it at 5 volts. This is a ground and this is 5 volts. So our circuit is working and the output voltage is 5 volt. Now you will see that if we adjust our set value, the voltage will increase or decrease based on our value, our set value. Now I will set the set value to 10 volts or 11 volts. You'll see that we have 11 volts here, and we can adjust the output based on this. So let's just make it 5 volts, and let's see how the system will respond to loading or unloading. You know that if we load the system, the voltage will drop for a while, and Arduino must adjust the pulse width modulated signal because it will sense that the voltage has changed on the output. How it will sense this? It will sense it because we already made a feedback loop between the output and Arduino. So Arduino will see how much voltage on A1 pin and will adjust the pulse width modulated signal accordingly. So let's see now. You will see now when we switch the circuit, the pulse width modulated signal will increase slowly until we have the voltage we need. Let's do this once again. You will see here how the pulse width modulated signal is adjusted. Here you see it is adjusted until we have 5 volts. Okay, now let's switch this load switch on and off. I will switch it on, and you will notice that the voltage will change and it will be adjusted. And now if I switch it off, the voltage also will change and the pulse width modulation will be changed by Arduino, and it will be adjusted to return the output value to its initial set value. Maybe you didn't notice the change because this is a very small time division, but let's see how it will work if we decrease the time division. You see, now when we switch the load on and off, the voltage sometimes drop or sometimes increases, and Arduino adjusts the pulse width modulated signal based on the changes. So let me show you how. I will open the switch here. You see here there is a change in the voltage, but the pulse width modulated signal also is changed by Arduino, and the system will come back to its state. Now if we load the circuit here, you will see that the system adjusts itself. This is a typical response of a closed loop system. You will see these oscillations in a closed loop system because it's always adjusting itself. Now if you look closely, you will see that this change took only 2 divisions of time, and since we have 5 millisecond division, so it actually adjusts the voltage within 10 milliseconds. So within 10 milliseconds, the voltage, if we load the circuit or unload it, the voltage will maybe go to 6 volts or 5.5 volts, but it will be immediately adjusted by Arduino using the pulse width modulated signal, and within 10 milliseconds it will go back to its normal voltage. So our circuit is working. In the next video I will show you how we will build this circuit in real time. But for now, let's see the code for Arduino quickly. We will not go into details for this code, but we will just see it quickly so you can understand what we are doing inside the Arduino. So to see the code for Arduino and to see how Arduino will work, we will start by defining potentiometer at the analog pin number 0 of Arduino. We will define also the analog pin number 1 as a feedback pin. We will define the number 4 digital pin as the pulse width modulation, pulse width modulated pin, and we will also define a variable to hold the value of pulse width modulated signal to feed it to pin number 4. In the setup, we will set the potentiometer pin as input, the feedback pin also as input, the pulse width modulated signal, which is pin number 4, as output. So we will also define the divisor for timer 0. This is important to set the frequency of the pulse width modulated signal. If we define the divisor as 1, then timer 0 and the pulse width modulated signal on pin 4 will be 62,500 Hertz. You can use multiple settings in Arduino, so you can refer to Arduino manual to see how you can set other values of frequency for this pin. Now in the loop we are doing a simple job. We are analog reading. We are reading the analog signal on the potentiometer pin, which is A0, and we store the value in the voltage variable. We also analog reading the feedback voltage, and we are storing it in the output variable. And then we compare the output with the voltage. If the output is less than the set value or the voltage read by the by the potentiometer pin, then we will increase the pulse width modulated signal. We will increase the duty cycle of this pulse width modulated signal. And if the output voltage is larger than the set value, we will decrease the pulse width modulated signal. After doing this, we will tell the pulse width modulated pin number 4 to use this new value of duty cycle to produce the pulse width modulated signal. Now this loop will loop indefinitely and will always sense the output, compare it with the set value, and adjust the pulse width modulated signal accordingly. Thank you for watching this video. Please like and subscribe, and if you have any comments, please comment down in the comment section. And if you want to know more about Arduino and more about how it reads the analog signals and how it produces pulse width modulated signals, you can also comment down in the comment section, and I will make some videos to let you know more about Arduino. Thank you again, and we will see you in the next video.